Good evening, everyone. This is the session number 1 from the playlist of properties of matter. So this is basically the introductory session, and here I have written these 15 points here, which will be covered in through this playlist, and the topics which will be covered in this playlist are the elastic behavior of materials, what are the different types of stresses. I will be discussing in detail about the stress-strain relationship, the Hooke's law, the modulus of rigidity, what are the thermal stresses and strain, fluid statics, Pascal law, laws of rotation, viscosity, streamline and this turbulent flow, equation of continuity, Bernoulli's theorem, Bernoulli's principle, the surface tension, capillarity, etc. So these are some of the main points which will be covered through this playlist, that is the properties of matter. So to begin with, let's first of all discuss about the first topic, that is the elasticity. So what is elasticity? So I have written here the basic definition of elasticity, which states that the elasticity is the property of a body by virtue of which a body regains or tries to regain its original shape and size when the external deforming force is removed. So this is a basic definition of this elasticity, and basically it is the property of a body by virtue of which it tries to regain or it regains the original shape and size when the external deforming force is removed. Now let's come to the second important point, that is the stresses. So here I will be discussing about the three important types of stresses. The first of all is what is a stress? So stress is basically the restoring force per unit area of cross section of a deformed body, and here this stress is denoted by sigma, which is equal to F upon A, where F is the restoring force and A is the cross sectional area of that deformed body. The SI unit of the stress is Newton per meter square, or this can be also expressed in terms of Pascal. Now stresses are basically of three types. The first one is the longitudinal stress, or it is also called the normal stress. Second one is the volumetric stress, and the third one is this shearing or the tangential stress. This tangential stress is also called the shearing stress. So what is the longitudinal stress? The longitudinal stress, in the longitudinal stress, the deforming force per unit area is applied along the length of the object and perpendicular to the cross section of the body. So here the formula for this longitudinal stress is equal to Fn upon A, where Fn is the magnitude of the deforming force and A is the cross sectional area of the body. Now here the most important thing is that if the length of the object is increasing, then we call it as a tensile stress, and if the length of the object is decreasing, then we call it as a compressive stress. Second important point is the volumetric stress. If the applied force produces a change in the volume and density, but the shape doesn't change, then we call it a volumetric stress. Here also the formula is given by Fv upon A, where Fv is the applied force and A is the cross sectional area. Now comes the last one, that is the shearing or the tangential stress. So it is the force applied tangentially to a surface and it produces a change in the shape of the body, but the volume remains the same. So these are the three important types of stresses which we normally encounter, and in the next session now I will be dealing in detail about this stress strain relationship and the Hooke's law. So till then, have a nice day. Bye.